Hey everyone, welcome to this fireside chat on all things observability. I have with me Viktor Farcic, who is the dev advocate at Upbound. He's written books on DevOps. He's the host of the DevOps Toolkit series on YouTube, which everyone should check out. And we have Shmuel Kliger, who is the founder of Causal, which is a new platform on the scene that helps teams reduce their observability noise and pinpoint root causes. And he's had over 2 decades of experience in what was once called IT operations and has sold companies to Dell and IBM. And so there's a lot of experience here in this chat. And so I think a good way to start, and maybe I should introduce myself real quick. I'm Adam. I'm the founder of 10K Media, which is a PR agency for DevOps companies. So I've worked at Datadog and have my own thoughts on the general market, and happy to help moderate this conversation. And so let's start off with a definition. I think at a high level, people agree that observability is somewhat the ability to understand what's happening inside of a system based on its outputs. And I think it's distinguished from monitoring in that in the monitoring world, you need to predefine alerts and thresholds that you're curious about, where with modern observability, ideally, you can be more real time and ask questions that you didn't know to ask before they happened. Do you both agree with that rough definition, or would there be any disagreements? And I'll start with you, Viktor.
Yeah, it makes sense. I mean, I'm not very into defining with single word because that's always complicated. You have dozens of people claiming that it's, if you mention DevOps, we're going to have like 2 hours conversation about what it is. Yeah? But let me say that, yes, today we assume that it's more than just defining in advance what you expect it to happen, but you need to be able to react to unexpected.
Shmuel, what do you think?
That's a very interesting question for me. To be honest, at first glance, I actually didn't see a huge difference between monitoring and observability, I must admit. And you can argue that it's just rebranding the same thing, because what is monitoring? It's collecting data and slicing and dicing that data and presenting it to human. Fundamentally, that's what observability is. To be honest, in the middle, we had a period that everyone was talking about AI ops, which was kind of a layer of analytics. Then it was the buzzword du jour a few years ago as a layer of analytics on top of monitoring. That has kind of faded away for a variety of reasons. So now we are maybe rebranding it with observability. At the core, fundamentally, I believe it's actually the same thing from day one. We collect data, we trend the data, we alert on the data, and we present it in some form, slicing and dicing it, and presenting it in some form for human. Yeah. And monitoring observability in that sense are the same for me.
But in our industry, if you don't put a new name to existing thing every few years, it doesn't exist.
Yeah, that's true. You got to stay fresh. And obviously the marketing people drive some of this, right? And that's why some of the terms like AI ops, and although I do think that was started by Gartner, or at least really evangelized by Gartner, people start to eye roll a little bit. And we'll get into the AI ops thing and what happened there, but I want to save that a little bit. But okay, so we all agree that all of our modern systems and modern applications are generating, a lot of things are happening, there's a lot of data being generated, and engineers need a way to troubleshoot and find the data they need when things go wrong. And there's a lot of tools out there to do that. So I think people are drowning in tools, they're drowning in data, they're drowning in alerts. Is the problem only getting worse on those 3 things I just touched on? And maybe Shmuel, can we start with you on that one?
I believe so. I believe that monitoring, observability, you name it, is what I call in a journey to nowhere. And the reason is that because if you think about how this space is evolving, for every little technology out there, for every little function that needs to be performed on that little technology, there is a little tool that will do something, will collect the data, will threshold and alert. So what we end up is with this nightmare of collection of tools. For every little technology, I have a little tool. And there is no intelligent built-in, there is no semantic built-in to connect those tools to a solution that provide actual value and actual purpose to the user. So we end up with this nightmare of endless number of tools that the humans have to deal with them, and the humans needs to bridge the gap between those tools.
Yeah, well, and I think,
would,
Victor, just over to you, I just wanted to say real quick, because I think people criticize Datadog a lot, but that is sort of what they're trying to be, right? Is this central, we just do everything. And maybe they don't do everything super well outside of their core competency of infrastructure monitoring. But I think the reason why Datadog is still so popular is because it gives you a checkbox on all of the, instead of having to glue together various point solutions. But I know, Victor, we talked about this offline. When you get that Datadog bill, that's a shock to the system, or it can be. So how do you think about this, like, best of breed point solutions versus single pane of glass observability problem?
Yeah, so backtracking for a second about having too many tools, I don't think that that's a problem. I actually think that having many tools is often welcome, because if we don't go for many new tools, then we would all be stuck with mainframe, right? That's what we would be using today. We are not using mainframe because new tools are coming and they're improving on what we're doing. We might argue that maybe we have too many instead of just many, or things like that, but we need new ways to do things better, right? The problem is not that. The problem is, how can we figure out standard interfaces through which those tools can talk to each other and expose data and do whatever they need to do, right? And that's where we are moving right now, whether consciously or unconsciously, right? We got standard API to define state of things, and that standard API is called Kubernetes, right? We have somehow standard APIs for metrics, which could be OpenTelemetry or Prometheus format, and traces, and so on and so forth, right? So the problem is not saying that too many tools is a problem, would be saying that too many people speaking is a problem. That's not the problem. Too many people speaking different languages in the same conversation, that is a problem, right?
Well, so maybe to push back a little bit, and Shmuel, I'd be curious your thoughts here. I think as an engineer, we all understand that the end user engineer wants to be able to pick the tool that they want to do for the job, right? But I think at scale, at an enterprise that's got, they're paying for multiple tools across multiple teams, and they're not necessarily, all the teams aren't on the same tools, et cetera, et cetera. You could see how this would cause issues in at least in a business sense. And Shmuel, what do you think?
So,
are you struggling with this?
So let's when I was, Kubernetes is not a tool, and OpenTelemetry for me it's not a tool. When I talked about tools, I'm talking about in the space of the management, the space of the observability and maybe other management function, that we are providing a little tool to do a certain function. OpenTelemetry and such, and what Kubernetes is exposing, those standards must evolve. You have to have this instrumentation in place. If you think about OpenTelemetry is a huge trend that is critical to make things more manageable. You have to have it. It's, if you go back to the days of the network, that's like when we had network management, we came out with SNMP, which was the standard way to manage network devices. You have to have things like that, and OpenTelemetry provided it basically comes up with the right standards of how to manage properly distributed applications, and you have to have it. But at the end of the day, that OpenTelemetry and those standards not providing a solution. The solution has to be built on top of those standards. And the question is, are we building the solution as a solution, starting with the purpose of that solution, or are we building a collection of tools and let the human figure out what to do with those tools and how to solve the problem that they are trying to solve?
True, but if we agree on the tool, whichever the tool would be, then we don't need a standard. The tool becomes a standard, right? The existence of OpenTelemetry is to facilitate having multiple tools.
No,
right?
so
Otherwise,
hold a second. So I'm not suggesting that there is one. First of all, maybe we should move away from the world is the world of observability and management in general is flooded with different tools for human to use, and maybe we should actually move from tools to systems that actually do something rather than tools for human to use. But I'm not suggesting necessarily that there will be some magic system that does everything, because that's a very big ocean to boil. Having said that, I do believe that on top of the raw data or the layer of instrumentation that is a standard that will be standardized, hopefully, you need to have what I call a layer of semantic that doesn't exist in that instrumentation. A layer of semantics that enable you to describe in a meaningful way the world that you are managing, and using that as a foundation to build multiple analytics that collaborate together with a purpose, which is the solution that the human needs to have. Now, whether all of those analytics will come from a single source or a single vendor, probably not. But the better they build on a common abstraction or common semantics, or now especially in the world of LLMs, on what I call on a common ontology that capture and describe the world, the more powerful solution we will be able to provide to manage environments.
So if I can just maybe get right to the root of what you just were talking about, Shmuel, because it seems like the problem isn't necessarily tool sprawl in the sense that people use different tools for different jobs, but it's that there's still a human that needs to make the connections across them. And that's sort of the mission at Causal, right? The company you're working on is to provide a layer above those tools that actually has actionable insights that it can deliver to the end user. Is that fair?
Fair, correct. I mean, the issue is that you have, I believe, that you have to provide a layer that describes the world. I call it a layer of semantics. People now refer to this as ontology. You have to have that as a foundation to build the right solution. Because without that, the intelligence stays within the human brains, and only humans will be able to bridge between the different tools to derive or deliver a solution.
Right. So this is one of your more, let's say, hot takes, right? Which is getting the human out of the loop, right? While everybody else, when they're talking about AI, is always obsessing about how to keep the human in the loop. But it seems like you think we need to arrive at a place where we remove the human more and more from these troubleshooting processes. And Victor, I'm curious your opinion there and how you feel humans and machines should be working with one another to solve these complex problems.
So if the question is, do I think that would be great if we could remove humans from the loop? I say yes, 100%. Are we there? Not even close, right? There are certain things that AI, in whichever form you want, is good at today, better than we are. And there are other things where it's just horribly bad, right? Like it is much faster than me. It knows much more than me, yet it has no context other than rudimentary, right? So for example, and I'm talking about today, not where I want it to be, just to be clear. It can go through my system and find out issue relatively fast. Yet it is completely incapable of realizing that that's not an issue because we have, within our organization, we figured it all out already in terms that, hey, no, yeah, you're seeing memory leaks in Jenkins. And by all measures, that's an issue. Yet we know that Jenkins just does that. It just crashes every day, and then we restart it every morning, and it's fine. We know we shouldn't be using it, but we're stuck with it, so there we go, right?
But is there no way
But isn't it someone in Jenkins actually should figure out to avoid those memory leaks and avoid those crashes?
Yeah, we figured it out. Don't use Jenkins.
Well, no, okay, someone that's responsible for Jenkins or can have the authority to remediate that should remediate Jenkins.
No, because Jenkins does not scale. And Jenkins is written in Java, right? And Jenkins has 15 years old architecture that is would be extremely expensive to change and so on and so forth, right? So you as a user, there is not much you can do except move away from it.
But
you as a developer, go ahead.
Yeah, just because I want to clarify one thing, because understood Jenkins may have issues naturally that engineers understand and you just deal with it and it's fine. It's not actually something that you need to be alerted on every day. But wouldn't a good observability system above that allow you as the human to mark, don't alert me on this anymore. I've already established this is no longer a thing that I need to get pinged. In other words, shouldn't the observability layer on top allow you to control for how much noise you're getting for issues that you don't want?
Yes,
I think that's part of a feedback loop that if you design a proper observability system, the human can provide that type of feedback. And it goes back to the point, Victor, I'm not saying that today, we are definitely far from the day that human can be out of the loop. Having said that, that doesn't mean that shouldn't be the desired state to which we are driving to.
Oh yeah, we both agree on that one.
And again, as I said, you are not going to get the magic bullet with a single system, and it might be a collaboration of analytics that get you there. The same way, it's not like that one day you'll turn the switch and says no humans are in the loop, but you'll never get there if you're not getting on a journey that reduce the human involvement in the ongoing operation of the environment. And that's what when I talk about taking human out of the loop, is more about, let's start by reducing the involvement of humans in things that we can inspire to do in software.
Oh yeah, I agree with that 100%, right? I usually get heated up on that subject mostly because, unlike in this conversation, we tend to have higher expectations from AI today than it really is. It's going to be amazing in the future, right? But then you hear all those announcements kind of, hey, you can write the whole application with AI. Yeah.
So just to be clear, I don't want to be the person in this conversation that come across as the big fan of AI, because I am not necessarily an AI fanatic, if you want, and I'm not. I'm providing solutions that you can argue has AI elements in them, but I'm more focused on what algorithmic solutions I'm providing than label them whether they are AI, machine learning, LLM, whatever. I'm not married to any of that, and I'm not the one that says. In fact, I would argue and actually we are putting a blog, we are writing a blog as we speak about the fact that you actually cannot do meaningful reasoning, especially vis-a-vis root cause analysis, with LLM or machine learning by itself. You need more than that. So LLM by itself doesn't get you to where you need. I'm not here talking necessarily about specifically how Causal does what it does, but we are not using LLM to do the root cause analysis, because I actually believe that LLM cannot do root cause analysis today.
Well, I think it might just be worth getting into what Causal does and how it does it and how you think about a modern approach to observability. But before we go there, I did want to circle back to something I asked Viktor, and it's open to both of you, which is the cost problem with observability. Because I think a lot of people watching a webinar about observability and the problems, if cost doesn't come up, it's a lapse of moderation duties on my part. And so, Viktor, it seems like actually from talking to you before, and Datadog is just a natural place to start because it kind of became the behemoth of modern observability, that it's a good tool at what it does, and there is value there, but the cost is so astronomical at teams at this point that any solutions to help them reduce the cost, whether it's maybe trying to embrace other tools or maybe just sampling data, not putting Datadog everywhere. I mean, how do you think about this cost problem and how do you navigate it?
I mean, Datadog is special that I'm yet to meet a person who does not complain about the cost, which is astronomical.
Right.
But I'm also yet to meet a person who is moving away from it. So it's a very strange beast that you say this costs arm and leg, and yet we have no immediate plans not to use it. So and I cannot really explain why is that so, right?
Well,
usually
because of observability is obviously very sticky, right? It's pretty foundational. After you have your infrastructure, you want to observe it. And so it's a tool that's adopted early and then you scale and it's everywhere. And it's not easy to rip and replace. So do you think that's part of it? Like if you were to start a new company, or if there's a founder of a new company today, would you recommend starting with Datadog, or would you say the cost of that gets sticky and too expensive at scale, and so you may want to look into other solutions, but for companies that are already bought in, it's just too hard to rip and replace?
I mean, if I would be starting a new company today, I would go with the easiest possible option, because in the early days of any company, the goal is not to have the best possible observability. The goal is to ship something, right? Observability is not the first thing on anybody's mind, or shouldn't be the first thing on anybody's mind when starting, right? Hey, okay, so I'm running in AWS or Azure or wherever, Google Cloud. Whatever they give me is fine. Not because it's really fine, but because I have much bigger problems. If we don't ship something by the next round of funding, we're toasted.
Right. But that's short-term, kind of day zero, day one. But now we're getting into day two operations, and you're a scaling company. Is this specifically an issue with Datadog, this cost problem, or do you think it's an observability problem more broadly?
It's a combination of things. It's of course it's a issue how much Datadog charges. It's also an issue of having unrealistic expectations about retention, and it's about not understanding the type of data you need, right? I can set up Prometheus and say I'm going to have a retention of 7 years, and that's fine, but I have zero rights afterwards to complain about the cost. And in this case, it's not even the cost of the tool or the license, it's the cost of simply storing all that data.
Right. And you said before that as an engineer yourself, you'd prefer to have more data now and you're less interested in the historical data. Is that fair?
Yes, because it's very hard for me to specify, to be explicit and say, this is the data we need, and we don't need this, because I'm dealing with unknowns, right? I'm not concerned at all about Jenkins from my previous example because we know what it does.
Right.
We know what are the problems we're going to encounter with it. What I'm very concerned about is I don't know what will happen tomorrow, right? Completely unexpected.
So, but what you're describing is the core of the issue. You're right. It's not about Datadog versus others. It's about the fundamental issue that we are collecting data, and we are collecting data without thinking what is the purpose and what I'm going to do with this data. And we end up collecting and storing and retaining data just for the sake of CYI, and maybe in the good case, 10% of this data is ever being used for any purpose. And so you're saying, well, I don't know because I don't know the unknown. Okay, maybe, but on the other hand, we are not investing any cycles in thinking, what is the goal of observability? What is the goal of what I'm trying to accomplish when I'm managing an environment? And drive and say, here is a definition of what the system of observability needs to do for me. And from there, say, okay, let me build the algorithm that will do that for me, and then tie that algorithm to the data and only the data that it needs, and drive from that what is the retention and what needs to even be retrieved from prem to the cloud. And by doing that, we will reduce dramatically the amount of data, and from there, the cost associated with the data.
I think we're talking about the same thing. I just want to make sure that I'm not misunderstood. When I say I'm interested, I don't know what I need, I'm talking about 1 day worth of data, couple of days, stop. I'm not talking about retaining that data any longer than that, just to be 100% clear.
Okay, but okay, let's focus on, for example, what we do in Causal. And so in Causal, we are focusing in doing what we call root cause analysis. And it's about inferring a finite set of root causes that may happen in an environment. And we build a solution to do that, okay? Now, I'm going to customers and I see they don't think that way. And as a result, they collect all kinds of metrics to solve the same problem, regardless whether these metrics actually relevant or can help them to infer those specific root causes. It's just because they are in the habit of collecting those data.
I agree, but a very quick question. That hypothetical customer, do they keep it beyond a day or two?
Probably yes.
That's the problem.
Well, so the argument that they make, which look, maybe they are wrong. They say, well, the main cost of the data is the cost of the cost of the ingress, the cost of pushing it to the cloud. The cost of keeping it is not so dramatic. So I'm coming to the right. Okay, we are minimizing the cost because we are not taking the raw data to the cloud. We keep it on your cluster. We don't take it. We keep it locally. But they claim that the cost, the main cost is the pushing it to the cloud, not the storing it.
Yeah.
Why would they push it to the cloud?
The ingress cost.
Well, to send it to like an observability thing.
What?
Why would they push it to the cloud? If they run on-prem, which I assume is what that specific case is doing.
No, I'm not talking on-prem. They are running on the cloud. They're collecting the data. Let's say that they have a Prometheus or whatever, or Datadog that collect data on their cluster, but then the solution, the Datadog solution, will take this raw data and will push it to the cloud, to the backend, to be stored and to be analyzed, to be stored, and so on. And
Yeah.
the cost is not the storage, according to those customers, the cost is the push of the data from their own cluster to the Datadog cloud.
Right.
And Datadog is just an example. I'm not.
Well, and that's why I let me just interject here, because I think I get what you're saying. The storage of data, there's solutions that are making that cheaper and cheaper, but also there's more and more of it. So there's a little bit of a paradox there. But it's when you actually send it to Datadog or whatever the vendor is, and they process it and analyze it and visualize it for you, that the costs start to come up. And that's why I'm seeing BYOC sort of bring your own cloud solutions to observability that are interesting to consider, to try and wrestle with this problem. But ultimately, it reminds me of the saying, there's no solutions, only trade-offs, right? And it seems like, Shmuel, in your mind, the modern approach to observability, where you just collect everything, right? And that was a big part of the pitch, I remember, at Datadog, right? Just install it everywhere. But as applications have become more complex, and obviously AI is really expediting how quickly applications are being shipped, and costs are rising. It seems like, Viktor, your solution to it is, I want all that data now, but I don't need it forever. I just need it for real-time troubleshooting. Where, Shmuel, it seems like you're willing to trade off some visibility in exchange for less noise, right? You want, instead of the bottom-up collect everything approach, you want to try to be a little more focused on collecting what matters and mapping root causes and actionable insights to that data. But maybe you would acknowledge that's exchanging some visibility gaps, and you may not catch everything, right?
Yeah. Yes. Look, there's some law of physics. There is, to your point, there is always trade-offs, and you have to make some trade-offs. And look, I mean, for example, some financials will say, no, I have to collect all the data and I have to retain the data because I have all kind of regulation and compliance issues and whatever. Yeah, they have to do it. I'm not here to say don't do it. I mean, that's what they need. My point is that my point is that the starting point to whatever we are building should be what I'm trying to accomplish, and then figuring out what data I need to collect in order to accomplish that, rather a situation that we are facing, and it's not new, we are facing it in monitoring for the last 3 decades and maybe even more, where people are, kind of quote unquote, too lazy to invest the intellectual time to figuring out what do I try to accomplish. So they say they kind of taking the intellectually easy route of, let me collect everything and then I'll figure out what to do with this.
Well, let me kick it over to Viktor, because I think Viktor brought up earlier the unknown unknowns, right? Like it's how do you wrestle with this idea of, okay, so Causal is building out essentially a database of likely root causes, and then tries to map that to the problem and identify that without much human intervention, or at least reducing it. But that still is acknowledging that Rootly is saying out of the box, these are the things that can go wrong, and when they do, we'll try to map it. But what about, Viktor, the cases where something goes wrong that you just did not expect or you couldn't have prepared for? Do you think, in your opinion, Viktor, all of the data does need to be collected? It seems like everyone agrees retention, depending on, maybe there's regulated industries where it's necessary, but that's a cost that maybe customers can shave if they're a little more focused on real time. But it seems like, Viktor, you're not necessarily agreeing with Shmuel that you don't have to collect everything, and that there's an advantage to collecting a lot because you may need it.
Yeah, where we might agree or disagree, I don't know, Shmuel will say, I'm really talking about very short time frame. I'm talking about day, right? Maybe not even that, maybe few hours, right? Kind of disaster just happened, right? And I have no idea what's going on, right? Now, if you're talking anything beyond that, let's not even go a day, a few hours.
Right.
I couldn't care less.
I think, not to go in circles, I think we agree the retention is a different thing, and that can be, but even in the real time, I imagine, okay, something goes wrong. all of that data that you are collecting, if there's an easy way to sift through it and pinpoint, okay, then that data is
Yeah.
good. But if the extra tools and the extra alerts and the extra data, even in real time, that's not relevant to the problem, that's all noise that you have to navigate through, right?
Depends. Let's focus. Are we talking about a dashboard or alert or querying? Pick any.
Okay, let's say, well, if you have the dashboard set up, I assume that means those are already predefined what you're
Yeah.
interested.
So if dashboard is using 10% of my data or 100% of my data, dashboard is what it is. It is using that data that is using. Whether there is more data behind it is not really going to affect it, except for performance, of course, always, right? So dashboard is not a problem because that's predefined. As long as you have the data the dashboards need,
Right.
doesn't matter whether there is more or no.
Right.
Alerts are also predefined. The real challenge comes with querying, right? More often than not, dashboard will not give me the cause of the issue.
Right.
Dashboard will give me an indication or alert. Hey, there is an issue. And then you start querying. Then you're doing PromptQL type of requests, right? And then that's the area that I'm very interested in. And we can skip the discussion whether you should have more or no, right? That's really the area of how experienced you are.
So my belief that you don't want to react. So what happened today, you're right. I'm monitoring a service and the service have high latency and I'm a user getting the high latency alert or I see the trend on the dashboard, it doesn't matter, and I see high latency on a service and the user is now chasing that and query and whatever, trying to figure out what is the root cause for that high latency.
Yes.
I say this paradigm needs to change because I don't think humans needs to react to high latency. The high latency should go into software that analyze all the high latency, all the anomalies that you see in the system right now, and based on the collection or the combination of anomalies that you see, that the system sees right now, be able to infer, oh, all of those degradation that you're currently seeing is because of this, and pinpoint and infer this. So the user then can look at this rather than chase the anomaly of the high latency.
Yeah, and Shmuel, I've heard you say this before, right? Stop chasing alerts, chase root causes, or some variation of that. And I get what you're saying, but my question would be the inference tool, whether that's Causal or something else, that's sort of connecting all of those various alerts to the actual root cause, which is more important to focus on than necessarily the individual alerts, which may be noisy. But don't you still need to collect all of that data in order for the inference tool to do its job?
Yes, you collect the data that you need in order to do the inference.
That's the tricky part, the data you need. How do you know ahead of time what the data you need will be? I think Victor's point is you don't know, so I collect a lot of it and I just don't hold on to it for that.
Well, that starts with the description of the world. So you have to build it on top of some description of the world and not the raw data. So you have the raw data that is being collected by Prometheus or whatever instrumentation you have in place, OpenTelemetry, whatever. What you have to take this data as a source that populate a description of what are the entities that you care about, what is the relationship that you care about those entities, what are the possible root causes that can happen, how will those root causes will propagate through those relationships, how will those propagation will cause anomalies to manifest themselves and be observed in the environment. You capture that in a description that is defined in a generic way, and by doing it, when the solution, when it runs, it will collect only the data that you need in order to feed that description, which is much less than the data that we are collecting today, not having in mind that description.
Well, let's ask Victor. This makes a lot of sense to me. I think we talked about this earlier, and you already acknowledged that there may be visibility trade-offs with the approach, but it's much less noisy. Victor, could you imagine, as an engineer yourself, a world where there's more proactive, predefined things that you want to collect, and you set that up front, or do you really think your approach of collecting everything now, but for a shorter period of time, is still the ideal way to go about the problem?
So if I understood Shmuel's argument, I agree completely with it. I just don't think it works in practice. Assuming that by the description of the world, we mean I describe the world. I mean, we couldn't, in like 50 years or 60 years, we couldn't even get to the point that even user-facing documentation is up to date, right? Written by me. So,
Well,
yeah,
no,
go ahead.
Keep going. You will.
So
Yeah,
if we could somehow figure
out
out, if we could have a system that does that description of the world or whatever the phrasing is,
yes.
Yeah, I'm all for it. Now, if the expectation is I, as an engineer, write it, yeah, I want to do it. In reality, I won't keep it up to date.
So the description, so the expectation is not that every engineer and every customer, every environment will write their own description, but rather that you come up with a description that is generic, that will work in any environment once you discover that environment. And so just to make sure that we are all on the same page, I'm not coming and tell you that I can deliver you a solution. Again, let me focus on the root cause analysis solution. A solution that will be able to infer all possible root causes that may happen in your environment. This is an unsolvable problem. And anyone who claims that, you shouldn't believe them. But I would say to you that there is a way to deliver a solution in which I capture, let's say, 80%, 90% of the possible root causes that will happen in an environment. And when each of those root causes will happen in that environment, it will correctly infer them, which implies that if there is some root cause that is not in this 90%, let's say I come in and say, here is a solution that will infer correctly 100 root causes. And 100 root causes is type of root causes. So it can be 1,000 and 100,000 in any given environment. But that means that if any of this will happen, it will infer it correctly. If there is another unknown root cause, and the unknown, the solution won't be able to infer it. And if that root cause happens, yes, the solution doesn't tell you anything. So, but because we all have to understand that fundamentally, so you can argue that going back to the beginning of the conversation, humans will never be out of the loop, maybe. Because there's always an unknown thing that may happen that software cannot predict or cannot know, and human will have to look at something. But if we get to a point that 99% of the cases, software can correctly infer the root cause, I'll take it.
Yeah, and I think we're on the same. Yeah, I think I was about to say, I have a feeling we're all on the same page there. And I think, even if 80-20 becomes, that's a typical Pareto distribution, which you see that breakdown in multiple places. And if you can get 80% of the value with a tool that accurately correlates root causes to the observability data, then maybe it's worth losing some visibility in exchange for less noise and more accurate insights in real time. And it's worth, acknowledging that that's the distinction, Victor, of, is the engineer have to write this world for themselves, or can they rely on a platform that sort of inherently captures this world and you just have to send data to it? And I guess that's what Causal is trying to build, and Causal would acknowledge it's not all the way there yet, but this is the ambition. I want to pivot because I think we exhausted that topic to OpenTelemetry as a open source project, as a popular open source project, and as a standard for collecting observability data. Viktor, we talked about this offline, and what I was curious about something you said, which is that OpenTelemetry is very good for metrics, but maybe, what is that right?
Traces.
Or traces,
Yes.
yes, but not so much, sorry, for the metrics or the logs. And you maybe use Prometheus for something like that. But isn't the whole goal of the OpenTelemetry project to create a standardization across all observability data? And if you're only using OTel for traces and then you have Prometheus for metrics or however your tools break down, doesn't that sort of undercut the whole ambition behind the OpenTelemetry project?
It does, and eventually I'm hopeful that eventually it will be only OpenTelemetry, which probably will not be in the form it is today, right? Because there's a lot of garbage over there and it's all too bloated and what's not. But the goal is definitely that. It's just that I come from Kubernetes world, so kind of I'm going to contain my answer to that. Simply, Prometheus is always the first choice. And the other choices, including OpenTelemetry, might come later or not come at all. And when I say first choice, I mean for tooling rather than humans, right? Because if you go and say, you know what, I would want to do some canary deployments, right? That's observability, effectively. That's a process that is observing data and depending on the data, doing rolling forward or rolling backwards. Cool, easy. Nothing complicated there, right? Now, that tool is going to start with Prometheus. That's most likely the choice, right? And then we have a similar situation, or we had rather than have, that the gravity of Prometheus format, and I repeat format, not the tool itself, is so strong that it's very hard to break away from it, right? Now, would I prefer that it's actually only OpenTelemetry? Yeah, of course. Kind of like, is it so bad that it's just as much or even more for metrics Prometheus? Again, that's not bad either, because you can say, okay, so that's actually the standard for metrics specifically. It feels like there is still some battle going over those two formats, and especially in terms of adoption of the tools that need data in some form or another.
Shmuel, I know you think OTel is actually a very important paradigm shift in the world of observability. Can you talk about how you view the project?
Yeah, I mean, you heard me saying it multiple times, I think, and I actually mentioned it, I kind of mentioned it earlier today. OpenTelemetry is an important component of how we can properly manage applications, because till OpenTelemetry is out there, an application developer develop the application, throw it out over the world for operation to operate it, not thinking how that application can be managed. And then we, in operation, struggle to figure out, what is the application topology, how to monitor that application. So it's kind of the management come from the outside trying to figure out what's going on with this application. OpenTelemetry is shifting that paradigm and say, no. Part of the application, I will provide management with the necessary information for the management to be able to manage that application in terms of understanding, using traces, understanding the topological relationship, which service talk to which, and things like that. Some telemetries in terms of service latency and things like that that are critical to properly manage the application as a whole. And till the OpenTelemetry, it was 100% burden on the management. And now with OpenTelemetry, we are shifting it more towards the application itself, more to the developer to tell me if you want to be properly managed, here is the information that I give you. Now do with this information some meaningful stuff and manage me properly. And that's a very important paradigm shift that will enable us to create a much better managed environment for the application, especially in production.
Victor, do you have any comments to that? I think you might be on mute, or.
Oh, sorry for that. Yeah, I agree, and there is nothing I can actually say against that. Just the reality of the tooling. And again, I think that me and Shmuel might be looking at it from a different perspective. I
Right.
feel, and correct me if I'm wrong, that Shmuel is watching it from the perspective of observability, and
Right.
I'm watching it from the perspective of the tooling that uses observability data to do something, right? That latter part is a bit more complicated today because of that gravity of Prometheus format.
Well, I actually think I do agree with you that the beautiful thing about Kubernetes, there's a lot of complexities and whatever, but the one thing that Kubernetes does give us is a lot of instrumentation and a rich instrumentation in terms of how to manage that environment. So maybe if the world of application will be completely contained within Kubernetes, management of those applications might be simpler from the point of view of observability. The reality, though, that most applications are not purely Kubernetes. They are combination of services that go across Kubernetes.
Imagine a world in which actually those other things are also managed by Kubernetes.
Well, okay. That's good.
Like,
that would be nice.
Like, for example, your application uses storage, right?
Yeah.
And that storage is attached to Kubernetes somehow by Kubernetes, right? Kubernetes gives you already some information about the storage. Load balancers are also already, you use Ingress in your application. What does Ingress do? It manages resources outside its Kubernetes itself to bring you load balancer into the picture, and so on and so forth. And then we have items like ACK from AWS, ASO from Azure, and stuff like. Kubernetes is becoming an orchestrator of stuff, right? Which is I think that we are very early there, but it's very interesting also from the observability perspective, because if you say this is the thingy that manages your stuff, then actually that thingy becomes your point of contact from where you can extract data, right?
Yeah. Look, I mean, I'm all for Kubernetes to take over the world, because it will make our life much easier in that sense. Yeah. It's not a coincidence. If you look at Causal, we start with Kubernetes. Our kind of, if you want, our beachhead into a customer is Kubernetes. It's the easiest environment for us to manage. But if all we would have faced, everything is in Kubernetes, our life would be simpler. The reality is that the same way that the world is always moving and the same way that you're saying OpenTelemetry is not everywhere. So, okay, so the key is to build a solution that, okay, Mr. Customer, the solution does this. This is how it does what it does. It needs to be instrumented. What sources of instrumentation you have? You have Prometheus, great. You have OpenTelemetry, great. You have something else, great. We'll take it all, we'll stitch it together to drive the analytics that we want to drive in the solution that we are driving.
Yes. Okay. So we're up at time. I just want to wrap by talking about the failure of the AI ops movement and where things really are going. Because obviously with Causal, you've talked about autonomous reliability, and it seems like, Victor, you have no issue with the idea that we may get there, or we may largely get there, where systems are self-remediating and self-healing. We just aren't there yet. It seems like the problem with the AI ops movement, which really took off around 2016, 2017, was that it was making promises that it just did not deliver on, right? It became a lot of buzz and a lot of fluff from vendors that were not auto-healing and auto, whatever. But now it seems like we're at a place with the rise of AI and everything that's happening over the past year or two, where that reality is much more tangible, even if we aren't there yet. And so maybe start with Shmuel, because you've been in the industry a long, long time, and I'm sure you've seen all sorts of AI waves and things like that. What really, in your estimation, was the issue with AI ops, and why that project and that terminology really didn't take off, but why you still think the promise of an autonomous reliability future is still in the cards for everybody?
Well, the AI ops faded for an obvious reason. It was a buzzword created especially to drive marketing in big vendors, and it was empty shell. Under the buzzword, there was nothing. There was nothing tangible that a customer can take, deploy, and make it work. So it failed. And it wasn't the first attempt of big vendors to brand something and deliver nothing. And that's the reality in which we are playing for almost 3 decades. And I believe it actually go back to what the fundamental reason is, that those big vendors are not building anything in-house. They are acquiring the little tools that emerge out there, and then they are rebranding them, put a nice pane of glass on top of a single pane of glass on top of all of those tools, and give it to the user. But underneath that single pane of glass, the mess still is there, and there is no solution. So it leaves, the heavy lifting is still left for the customer to make it work and deliver value in their environment.
But then, just for my part 2 of my question, then, because I think we're in agreement there. But today, Causal could be branded as an AI ops tool, right?
Yes, but I want to be very cautious here, because I don't want anyone to take care and says, oh, here is a magic bullet that solves everything in the world. I go back to the fundamentals of how I believe you have to get on a journey to get to somewhere. And it starts with this layer that I was talking about earlier, which is this layer of semantic, layer of abstraction, ontology, you name it, you can name it any way you want, but fundamentally a layer that provide a common description of the environments that are being managed, the entities, the relationships and attributes and things that I care about that environment. It's very similar if you go years ago, after SNMP on the network, I don't know if you remember, there was a merged standard, it was SIM, the Common Information Model. And that was an attempt also to come up with a common information model to describe the IT environment from application down. But the point is that you have to start with that layer that provide a common description of the world that you are managing. And by the way, that description should be decomposed and abstract in different layers, and it needs to be hierarchical. I won't get into all the complexities that can evolve with that. And on top of that, build a collection of analytics that collaborate together to solve a problem. And so where I see Causal going is we start with that description. We provided a core, that layer of this that capture the semantics of the world that we are managing. And on top of that, we are building a collection of analytics. Are we solving all the problems of management of application in any environment with all the issues? No, but if you have that foundation, you have a foundation to plug in kind of pieces of Legos that eventually will solve the problem.
Okay. Viktor, in around 2017, I mean, you've been talking about DevOps for a long time, so I'm sure AI ops came across your desk and it was something you probably did podcasts about or talked about at least a little bit. Were you always skeptical of that movement? And do you agree it kind of failed in various ways? And do you think the potential future is still there? Those promises can be realized. It's just they weren't with that AI ops movement.
Yeah, I mean, whether it failed, yeah, it failed 1,000 times so far, right? And that's how almost every technology goes through this hype cycle that unrealistic promises are being made, and some of those promises will never be fulfilled, and some will, but not today, right? And I feel that that's where we are with AI right now, for a while now, right? It's becoming, there are things that are really amazingly good. Like LLMs know a lot, kind of more than me, kind of big thumbs up. What we're seeing now with agents, like I've been using for a while now a lot, Claude, right? It's absolutely amazing. Claude Code is blows my mind. It's still mostly useless, but it blows my mind when compared to where we were only half a year ago, right? So
Yeah.
I don't think when I hear news, we fired 80% of the developers because we are using AI now. I don't know whether to laugh or cry. Kind of like I'm not even sure what my reaction should be. So it's far from being the thing. But if you ignore the fluff, if you ignore the marketing part of it, and you look at where it's going, then yeah, this is foundational change that happens once in a generation, right? We just need to somehow ground our expectations and follow along, right? And I do think that there will be companies who will be late to the game, like many other technologies, and will not be able to catch up. And companies will disappear just as they disappeared in the past,
Right?
Because they're too late.
I couldn't agree more. I mean, what will kill this if we create expectations that cannot be delivered, and that goes back to what killed AI ops. I mean, LLM is very, very good in certain things, but if we start creating buzz around things that LLM actually is not so good about, it will kill it. So,
and you're talking about specifically observability, right? Because there is a trend.
Yeah, I'm talking about observability. Yeah. I mean, I'm far from being. I won't claim to be an expert in LLM, and I won't be. An LLM can do a lot of things, but in the context of what we are doing in observability and managing IT environment, there's things that LLM is very good. But if we'll stretch it to do something and create expectation that it does things that it's actually not good in doing, it will actually kill the good things that it can do.
I think
I can sign that.
Okay. Yeah, I think marketing teams, especially for engineers, right? Engineers are very scrupulous people. They're already skeptical of marketing, and it probably was a mistake to overhype some of these things. And I think the vendors who leaned in too hard and didn't deliver suffered some consequences for it in terms of brand reputation. And, so I think having a measured, realistic conversation that runs an hour, that might be what it takes to really get into the weeds of all this. So until next time, I'm Adam from 10K Media. Viktor, Shmuel, thank you so much for being generous with your time.
Thank you so much
for having us.
Thank you, Viktor.
Thanks, man. Guys, I need to run right away. I'm already